welcome to section 5.2. In this video, we're going to be going over word problems that require more than one step to get to the answer. So it is important when reading through word problems to understand, number one, what is being asked of you, or what the question is asking for you to solve specifically. And number two, it is important for you to interpret the data that you're given or the information that you're given and understand what to do with it in order to answer the question that's being asked of you. So with that being said, let's go through this first problem, read through it together, and then interpret some of the stuff that we're given. So in example 1, I encourage you to actually go through yourself and see if you can get to an answer. And then once you are done, you can unpause the video or resume the video to see if you got it correct. So assuming you have worked through it, example 1 says there are 9 garden beds and currently 4 times more trees than garden beds in the park. The park workers will plant 10 more trees today. How many trees will the park have when the workers are finished? So let's box that question. We want to know how many trees will the park have when the workers are finished? So that's our goal. We want to find out how many trees the park will have once the workers are finished planting their 10 trees today. And let's underline some important information. So we're given that there are 9 garden beds and 4 times more trees than garden beds. And we also know that workers will plant 10 more trees today. So with all that being said, based on this information, the first thing I would do is find the current number of trees. And to do that, we know that there are 9 garden beds and 4 times more trees than garden beds. So to find the number of trees that there currently are, we're going to take 9 and multiply it by 4. Because 9 times 4 is 4 times more than 9. So 9 times 4 is 36. So we have 36 trees currently. And then our second step is to add the 10 more trees. So we're going to take the 36 and add 10. And 36 plus 10 is 46 trees. And that is our final answer. So looking at example 2, I encourage you to pause the video, and now let's work through it together. So it says, a teacher has 234 pieces of candy. If there are 18 students, 7 of whom are boys, if divided evenly, how many pieces of candy will the boys get in total? So there's a lot of information there. So let's first start by finding out or boxing what the question is, what's being asked of us. And this is our question. How many pieces of candy will the boys get in total? And now let's underline some important information. We know that the teacher has 234 pieces of candy. We know that there are 18 students in total. And we know that 7 of them are boys. So with that being said, our first step to do with this data is to, we want to know how many each student in the entire class will get. So we're going to take the 234 pieces of candy and divide it by 18 students. And if you divide 234 divided by 18, you'll get 13. So that means each student will get 13 pieces Well, 13 pieces per student. And then now that we know how many each student is going to get, we want to know how many pieces of candy in total the boys will get, and that there are 7 boys. We're going to take 7 boys, and then we're going to multiply the 7 boys by 13 to get the total pieces of candy that the boys will get. And 7 times 13 is 91. So we get 91 pieces of candy. So looking at problem 3, it says Luis and his family left their house for Breckenridge, Colorado at 8 a.m. They stopped for food around 8:57 a.m. And when they finally arrived at Breckenridge, the time was 10:35 a.m. How many minutes did this trip take Luis's family? So let's first, as always, box the question. We want to know how many minutes did this trip take his family. Now, how many hours, we want to specifically know how many minutes. So let's underline important information. So we know that his family left their house at 8 a.m. And because of the question, it's asking how long did it take them. This sentence where it says they stopped for food around 8:57 a.m., that's kind of irrelevant based on the question. So let's just cross that sentence out. And then we have when their family arrived at Breckenridge, the time was 10:35 a.m. So based on this information, our first step is to find the difference between 8 a.m. to 10:35 a.m. And the difference is going to be 2 hours and 35 minutes. And then our second step is to convert the 2 hours and 35 minutes to minutes. So to do that, we're going to take the 2 hours and we're going to multiply that 2 by 60. And the reason why I'm multiplying by 60 is because there's 60 minutes in an hour. So to find out how many minutes are in 2 hours, we're going to take that 2 times 60. And then we're going to add on that extra 35 minutes. So once you do this, 2 times 60 plus 35, you get 155 minutes. And that is your answer. Looking at example 4, I encourage you to pause the video and try this on your own. And assuming you have worked through it, let's talk about it together. So it says Joe has 7 pencils and 6 erasers. Sam has 3 times more pencils and half the eraser Joe has. How many pencils and erasers do Joe and Sam have all together? So let's first start off by boxing the question. We want to know how many pencils and erasers both Sam and Joe have. We know that Joe has 7 pencils and 6 erasers. We also know that Sam has 3 times more pencils and half the amount of erasers. So with that information, let's first, let's find total amount of pencils. So to do that, we know Joe has 7 pencils, so let's write that down. And we also know Sam has 3 times more pencils. So we're going to add that. We're going to add 7 And then because Sam has 3 times more, we're going to multiply that 7 by 3. And if we do this, we're going to do 7 times 3, which is 21, and 21 plus 7. So we're going to write that down. 7 plus 21, that's 28 pencils. And then for our second part, let's find total amount of erasers. Oh my goodness. So to find the total amount of erasers, we're going to take 6, because we know Joe has 6. So let's start off with that. We're going to do 6 plus, and then we know Sam has half the amount of erasers. So to get half the amount, we're going to take 6 and divide it by 2 to get half the amount. So according to PEMDAS, we're going to start with division. So we're going to do 6 divided by 2, which that is 3. And then 6 plus 3 is 9. So we have 9 erasers. And those are your answers to the question. Now, looking at our last couple examples, these next couple ones are a little bit more difficult. I will say that, but we can get through this together. So with that said, I encourage you to pause the video and try number 5 on your own if you haven't. And assuming you have worked through it, let's go through it together. So it says your friend has a vehicle that can travel 345 miles on a full tank of gas, which can hold up to 15 gallons of gasoline. However, your friend only has a quarter of a tank. About how far can your friend travel until they run out of gas? So let's first box the question. How far can your friend travel until they run out of gas? Let's underline important information. So we know that the vehicle on a full tank can travel 345 miles, and that a full tank can hold about 15 gallons of gasoline. And we also know that your friend has about a quarter of a tank left. So with that being said, let's think about our first step. So what I would do as my first step is I would find how many miles your car can travel per gallon, or your friend's car can travel per gallon, my apologies. So to find that out, we're going to take this 345 miles, and we are going to divide that by the 15 gallons of gasoline. And that is going to get us, this actually divides evenly, and you'll get it'll be 23 miles per gallon. So this means that for every 1 gallon of gas the car uses, you can travel 23 miles. Or you can travel 23 miles on 1 gallon of gas. Now, our second step, I want to figure out how many gallons is a quarter of a tank. So to do that, we're going to find what a quarter, we're going to find what a quarter of 15 is. Now a quarter is 1/4. So we're going to take 1/4 and multiply that by 15. In other words, that is 15 divided by 4. And 15 divided by 4 is approximately 2.25. So your friend has approximately 2.25 gallons left in the tank. Now our last step here is to multiply the two numbers that we got to find how many miles your friend has left. Because we know that we can travel 23 miles with 1 gallon. And if you multiply those 23 miles by the 2.25, you will get exactly, or you'll get the approximate amount the car can travel with a gallon of tank, or with a quarter of a tank. So let's do that. 23 multiplied by 2.25. And that is going to get you approximately 51.75 miles. So your friend can approximately travel 51.75 miles until they run out of gas with a quarter of tank. Now, looking at our last example, I encourage you to pause the video and try it on your own. And assuming you have given this a try, let's work through it. So it says, in high school, cross country has races that are 5 kilometers or 3.1 miles long. The fastest race, or the fastest time Mason ever ran a race in high school was 17 minutes and 52 seconds. Given that information, find the average pace per mile in minutes and seconds. So I'm not going to lie, this has a little bit extra stuff added to it because we have to do some converting. So for our first step, let's interpret the problem here first. So we want to find the average pace per mile in minutes and seconds. And then let's underline some important information. So we want to know the average pace per mile. So this 5 kilometers we don't really need. What we need is that 3.1 miles. And we also need that the fastest time I ever ran was 17 minutes and 52 seconds. So with that being said, the first step I would do, if you haven't thought about what the first step would be, I encourage you to pause the video and think about it. And assuming you have thought about it, our first step would be to convert the 17 minutes and 52 seconds. Wow, oh my goodness. 52 seconds into seconds. Now, if you're confused as to why, this will make a little bit more sense once we work through the problem a little bit more. So to convert into seconds, we're going to take that 17 minutes and multiply it by 60 because there's 60 seconds in a minute. And then we're going to add that extra 52 seconds at the end. And that'll get us a grand total of 1,072 seconds. And then our second step would be to find the average pace. To do that, we're going to take that 1,072 seconds and divide it by 3.1 miles because that's how long the races are. So then from here, we're going to find the average amount of seconds it takes me to run a mile. And that is going to be 345.806 seconds. Or I should say approximately. And then now our third step is to convert this 345 seconds Well, this 345.806 seconds in 2 minutes. Sorry, I got a lot of words going on here. But I just want to write out the steps, so that way, if you need to write it down, you can see what the math I'm doing is doing. So we're going to take this 345.806 seconds, and then we're going to divide that by 60 seconds, because there are 60 seconds in a minute. So once you divide that out, you should get approximately 5.763 minutes. Now we have one more step left to do, because if you notice here, we want our answer in minutes and seconds. So we're going to have to take this decimal that's here at this 0.763 and convert that into seconds. So to do that, let me write what we're doing here. First, convert 0.763 into seconds. Now to do that, we're going to take the decimal 0.763 and we're going to multiply that by 60 seconds. And once you do that, you should get approximately 46 seconds. So our answer, we should get about, or my average pace was about 5 minutes and 46 seconds per mile. And that is the answer to this question. Now, before I actually end this video, I will say on the homework and the test for this class, you don't expect a problem this involved. But I just wanted to put this as an example to see how we can apply rates like this and how we can do a little bit of converting to get to a final answer. You might encounter a problem like this, like problem 5, but you won't see problems like problem 6 on the homework or the test. So thank you, and I can't wait to see you for the next lecture.